Okay, so today we're going to talk about electricity, but before we can really talk about electricity, we need to understand charge. What is it? And then what are things that allow charge to flow, like conductors, and what are things that don't so much, which are called insulators? Okay, so what we're looking at here are two different materials. We can call them cylindrical materials. Those are my very poorly drawn cylinders. And anything that exists is made up of small particles, right? Which are these kind of little colored circles here with the different colored things in the middle and the yellow thing around the outside. We're going to call those our atoms. Okay. So those are the atoms that we're going to be dealing with. All right. So let me just make an arrow pointing to one of them and say, hey, that right there is an atom. Okay. Wow. An atom. Okay. And so let's get into it. So around the outside, we've got electrons. Use the right colors here. We've got electrons, and electrons are flowing around the outside of our atom, which is or outside of our nucleus, right? So the nucleus is the blue and the red colored circles, which is neutrons and protons, right? And so we've got three particles, right? We've got protons, we've got Jimmy Neutron, neutrons. That's how you spell it. I do that in my head, otherwise I forget. I think that's how you spell it. Yeah, I'm pretty sure. And then I did the yellow circle, which is an electron. Okay. And most of you probably already know from an earlier class that electrons have a minus charge and that protons have a plus charge. So, what we figured out was basically if you've got protons in your nucleus, these electrons are trying to be as close to them as possible. But there are other electrons out there, and the electrons are trying to be far away from each other. And the protons are also trying to be far away from each other. Okay. So, it's strange because it seems like there are these charges, these things that are pulling and pushing, and we just pretty much had to decide on an arbitrary name and designation for them. So we decided that protons possess a positive and electrons possess a negative charge. Okay. So the idea here is that protons and electrons, since they're opposites, they're attracted to one another. They want to be near each other. But electrons and electrons, they don't really so much. So let's zoom in on one of these atoms, shall we? If we're looking at it, and I'm gonna make a proton, and then I'm gonna make a neutron, I'm going to make another neutron. I'm going to make another proton, something like this, that. And then around the outside, let's say that our electrons are going to take, our electrons are in kind of like a cloud. That's why the circle is here. So a lot of early ideas of an atom show that electrons are orbiting the nucleus, which they are, but it shows that they're kind of taking a defined path, like they must travel around this dotted line or whatever, right? But that's not entirely true. Electrons are basically moving freely around the outside, kind of in a cloud. So you can imagine that they're kind of like moving wherever they want as long as they're around the outside of your atom. So if we have an electron here, we're probably not going to have another one like right next to it. I use that E minus to indicate an electron because these are too close together and they don't want to be near each other. So they're going to try and push away. Okay. So what you're more likely to see is that another electron is going to be, excuse me, somewhere far away like this. And the electrons are going to like kind of whirl around the outside of the atom, but not really in a defined path, right? So it like might go this way and then it might be like, nope, just kidding, going this way. And then it might like go across in three-dimensional space, right? Something like that. Okay. That doesn't really matter too much. But what you want to know is that like charges are repelling, opposite charges are attracting. We talked about that earlier when we learned about electrical fields. And this would be a really good time for us to kind of revisit that idea. And we might do so as we make this video. Okay. So next up, we want to talk about what the heck is going on with conductors and insulators. So we've kind of got the idea of charge. It's already kind of handled, right? So boom, charge done. Now, what's a conductor? What's an insulator? And you guys know already, conductors are things that allow negative charge to move freely, and insulators are things that don't really too much, right? So let's get into that. Okay, so when we are looking at our two objects, right? So let's call both of these are solids, all right? And one of them is an insulator and the other one is going to be a conductor. So let me just label them for you so you can kind of see. Okay, I'm going to say that the top one, insulator. Wow, a little bit of a lag. Insulator. Bottom one, conductor. Okay. So one's a conductor, one's an insulator. And we're talking about this with electric charge. You guys have already seen how this works with thermal energy. So we know that conductors are allowing a flow of energy a lot more easily than an insulator will do. So let's think about this. If these are both solids, okay, these atoms are fixed. They are all stuck together in a pattern, and that forms the shape of the object or whatever, right? So they're not moving around. They might wiggle a little bit or vibrate a little bit because that's kind of how particles move, right? So you know that like sound energy is going to move through vibrations and all of that, right? So that's great. But what we do know is that these particles are not really moving around. But what's interesting about a conductor is that the electrical charge that might exist in wherever it is around one of these atoms is actually able to move freely from atom to atom, right? So these electrical charges can move around if they want to. Okay. So we know that, sorry, I should just keep this consistent. There we go. We know these electrical charges can move around freely, but with an insulator, they're kind of stuck. They can't really go anywhere. So insulators don't allow the energy for the electrons to be able to transfer back and forth. So if an electron's like, I want to go see that atom, it's not able to. That's canceled. It's out. Can't do that. Sorry. Bye. Okay. So that's the big difference between conductors and insulators in terms of electrical energy. Okay, so here's the thing, right? We're not going to just get electrons flowing through a conductor unless we set up some sorts of energy, right? So we would actually probably want to hook up a battery, right? So maybe we're going to take something like this, a battery, and we're going to hook it up to our conductor. Once we do that, in this hookup wire, whatever it might be, there's going to be a flow of electrons, right? A flow of charge. Actually, it wouldn't flow unless you have it completed. We'll talk about that later. Okay. So, okay, we've got it hooked up. All right, great. So these electrons are now going to flow freely. Okay. And they're going to do that really easily. That's what happens in a conductor. Now, if you do something similar like this, so maybe we loop in our insulator to our battery like that, right? If we do that, right, we are actually going to be putting charge on this insulator, or we could be doing. And what will happen is the positive and negative charges that make up the atom will start to kind of shift relative to one another, right? So if we delete this right here, we can then take the atom and I'll circle it. I'll make a little bit bigger circle. We're going to end up with something like this, the plus going to one side and the minus going to the other side. The atom is still in the same place, but it's going to kind of separate based on charge. All right. So let's look at what happens after that. Okay, one more note on this insulator, right? So if all of the atoms that make up the insulator end up doing this thing where the charges separate, then this insulator, even though it's not really conducting electricity, is able to then interact with other charges near it. So you might be familiar with static electricity. That's kind of how this works, right? More on that in just a minute. Okay, so let's go ahead and then put charge on these things, shall we? So let's say that whatever you end up doing, you end up hooking up some stuff, or whatever. You're going to apply charge. You're going to end up adding charges to these materials, right? So let's add some charges to our insulator. Here we go. Just add charges randomly wherever we put them, right? If this is happening, right? When you add charge, you're creating a situation where the net overall charge is higher, right? So the atoms still exist that were inside the insulator before. We just added some extra electrons. So we've added some extra charge. So we built up a charge on this insulator. Okay. So the atoms are still there. There's some extra electrons that are sitting still, right? The key is on the insulator, these charges are stuck. They can't go anywhere. So wherever I apply the charge to using whatever thing I use to apply the charge, they're stuck there. Right. So let's say I was like, okay, man, I really want to charge the one side of this object. I could just be like, here, have a whole bunch of charge this one side, and it's stuck there. It can't go anywhere. Okay. That's what an insulator does. Now, let's say I put a charge on the conductor like this. When I put another charge on the conductor like this. Well, here's the deal. Since these are able to flow, charges that are like want to repel, right? So remember, the atoms are still here and everything, right? So let's assume that those all get canceled out because the positive charge of the atom and the negative charge of the atom naturally would cancel each other out. So those are having no effect. So any additional charge that we add, they're going to be like, yo, get away from me, dog, right? So this charge here is actually going to go to the outside of our shape, and then this one's going to go to the outside of our shape. So if we keep applying charges, they're going to keep wanting to be as far away from each other as possible, right? So you're going to end up with something like this, and you can imagine it like all the way around the outside. So these would be on the outside of your shape, right? Not on the inside. So that's why I'm trying to indicate that that's where they are, right? So these charges are going to actually sort, they're going to run and organize themselves in patterns. And so that's how conductors are going to work here, right? So these things can now flow freely, right? So they might end up all flowing in a direction depending on like which way you are applying some sort of electrical force, if you will. And the force again, electrical force is kind of that difference between that positive and that negative charge, or that negative and that negative charge, allowing electrons to flow in a specific direction. Okay, so let's then look at what are some materials that make good insulators, right? So things that make good insulators, you've got things like wood, you've got things like plastic, you got things like glass, right? Those are your good insulators, things that are not allowing the flow of electrons very easily, right? Then for your conductors, you've got things like, what do you think? I hope you all say, okay, basically all types of metals, right? So if we give you a subset of metals, you've got things like copper. We use copper in a lot of our wiring because it's pretty cheap relative to the other things. Like gold is really good, silver is really good.